So as we're talking about things in the Earth's atmosphere that will interact with radiation or energy we get from the sun, I should talk about the greenhouse effect. The greenhouse effect oftentimes is linked or associated with the phenomenon of global warming, the fact that surface temperatures are getting warmer. Now, instead of the greenhouse effect, I would rather call it the enhanced greenhouse effect. So I'll just cut to the chase before I describe it. Basically, carbon dioxide, we think, and I'll describe why, but carbon dioxide can have a warming influence when it's present in the Earth's atmosphere. And but carbon dioxide has always been there, but it's just we're putting more carbon dioxide into the Earth's atmosphere. So that's why I like the word enhanced. And what you're going to see actually is there are other gases other than carbon dioxide that add to this warming or this greenhouse effect. So enhanced greenhouse effect, global warming, greenhouse effect, it's been there forever. So the way the greenhouse, we have a greenhouse here to show you how the greenhouse effect works. So basically, remember I said you can use the abbreviation SW for shortwave radiation. So that would be, and it comes from the sun, so that would be things like maybe ultraviolet, visible light would be shortwave radiation, generally speaking. But just take visible light for now. Visible light can go through the panels of a greenhouse like this, and it will actually, visible light then will interact with the inside of the greenhouse. So it's interacting with the inside of the greenhouse, and as it interacts with the inside of the greenhouse, it will be converted into long wave radiation, and i.e. infrared radiation. And the thing about the glass panels is, although they let shortwave radiation in, they will not let long wave radiation out. And it's a very similar thing that happens in your car on a sunny day with your windows up. And say you have black upholstery, and so the visible light will come through your windows, interact with your black upholstery, heat up the inside of your car, and then your glass actually is a good thing to block infrared, thermal energy. So that's kind of what we got going on here. It's known as the greenhouse effect. Now I need to show you, instead of glass panes, I need to show you what in the Earth's atmosphere do this. So here we go. I got three figures here. The first one is showing you the incoming short wave energy from the sun. And and it interacts with, it's going to heat up the geosphere. And as the geosphere is heated up, notice now it's red. This is kind of the re-radiation of the geosphere into the atmosphere. And here you see two types of gas particles. These Mickey Mouse particles, they look like Mickey Mouse, those are water particles, water vapor. And then these that are kind of gray in the middle, two reds in the side, those are carbon dioxide. So now, if depending upon the amount of water vapor and carbon dioxide we have in the atmosphere, it's going to interact with that outgoing long wave radiation. And so here we show that kind of a scattering, a kind of a pinging of the radiation that was sent up from the surface of the Earth by those gas particles. So there you go. Those gas particles, carbon dioxide and water vapor, are selective for infrared radiation, unfortunately. So here are some variations in the greenhouse effect. This is kind of showing you, four blings of rays of energy. I don't know if 4 is necessarily significant, but it's showing you the Earth re-radiating. Okay, and here it's showing that actually 4 of them are returned by greenhouse gases. But if we go someplace like the moon, notice the moon doesn't have an atmosphere. It doesn't have any gas particles to go ahead and redirect that outgoing radiation. So the sun heats up, just like the Earth heats up, but notice that that re-radiation is just lost to space. Now, if we compare that now to a more extreme effect, where we see this actually is Venus. And Venus's atmosphere isn't nitrogen. The majority of Venus's atmosphere is carbon dioxide. So here we have the sun shining on Venus, warming up the planet, and here we see the planet trying to cool off, and actually, I'm not sure how you want to necessarily show this, but it basically retains a significant portion of the energy it's trying to re-radiate. Sometimes I've heard Venus's atmosphere and planet be described as a runaway greenhouse effect.